6.1 Objectives. Write the augmented matrix for a linear system. Perform matrix row operations. Use matrices and Gaussian elimination to solve systems. And use matrices and Gauss-Jordan elimination to solve systems. Okay? You ready? The first one is the hardest. Which I mean, not that hard at all, right? Here's the system. 2y minus z equals 7. X plus 2y plus z equals 17. And 2x minus 3y plus 2z equals negative 1. That's the system. I need this much room to show you how to do the problem. Okay? Because the first thing we have to be able to do is write the augmented matrix. You ready? What goes here? 0, 2, negative 1, 7, 1, 2, 1, and 17, 2, negative 3, 2, and negative 1. This is what you know how to do, right? Are you ready for me to make it an augmented matrix? Done. The other ones are slightly harder. Okay. Now, we could easily put this into our calculator in the matrix in a reduced row echelon form. Yes, ma'am? Yes, ma'am. He's on his way. Okay. All right. We need to work on knowing how to perform matrix row operations. Okay. So let me give you a matrix. 3, 18, negative 12. Ooh, just for fun, I'll make it an augmented matrix. Augmented. Changed. We both knew the definition of the word. I don't know how that's so exciting. That I have officers in. White's the president. Who's the vice president? Carter? Carter's the vice president. Andrew is the secretary and executioner. He hasn't. He asks. I say no. Yeah. Okay. Okay, just to make sure you understand the vocabulary of this stuff, we need to be able to call this R sub 1 and R sub 2 and R sub 3. Guess what R stands for? Row. Row 1, row 2, row 3. Okay? So one thing it might ask you to do, it might say, do this. What's our new matrix if it asks us to do this? What is it asking us to do? It's just saying switch them. So row 2 becomes row 1. 1, 2, negative 3, and 5. Then row 1, because row 1 has become row 2. And then row 3, we just kind of leave it alone. It's just still sitting there. Now think of what our answer has to look like when we actually solve these. And then tell me why we would want to do something like switch row 1 and row 2. Doesn't that have to be a 1? Remember, we have our diagonal of 1s and then this is our answer as long as the rest of them are zeros. Okay? So we need to be able to switch rows around to get things where we need it to be. Okay? Another thing we might need to be able to do is, starting from our original problem, not this answer, but starting from our original problem, we might need to do something like this. What is that asking us to do? Divide row 1 by 3. Each term, divide it by 3, right? And then what do I do with row 2 and row 3? Yeah, if it doesn't tell me, I just leave them alone. Last but not least, it might ask us to do something like this. 2 times row 2 plus row 3. So what do we do with row 1? Now, again, this is back to the original problem. Okay, so there's that. Now, most of the time when this happens, it's going to tell you where it wants the answer. For some reason, it didn't this time, but I know that the answer needs to go in row 3. Okay, so what do we do with row 2? Maybe I just didn't write it down. I just know that we're supposed to put it in the row 3. So what do we do with row 2? I multiply it by 2 and then add it to row 3. Okay, so 2 times 1. That took entirely too long. Plus negative 2. 0. 2 times row 2. 2 times 2. That was much faster. Good job. 4 plus negative 3. 1. Sometimes I just ignore it. It's okay. Negative 3 times 2 plus 4. And then 2 times 5 plus negative 6. Can you handle, you cannot have your calculator. Can you handle row operations? I don't know either. Are we good? Okay. In the objectives for today, there's 2 types of elimination. Gaussian elimination, Gaussian-Jordan elimination. Can I make sure you understand the difference between those two? Okay. I know it looks like it says Jordan. I also don't care what you think. What are we most used to? Because we've always wanted a diagonal of 1s, 0, 0s, because this is our solution, right? But there is this one. Do you see how this could still be helpful? This one tells me what z is. To find y, couldn't I take z and plug it in here to find y? And couldn't I then take z and y and plug it into this one to find x? It's just not, to us, it's not as simplified as this one is. It doesn't automatically tell us the answer over here like this one does. Okay? But you just got to pay attention to see what it asks for. Okay? Pretty positive that this is RREF and this is REF. This is reduced row echelon form, and this is just row echelon form. It depends on what they ask. So, are we doing this by hand or in the calculator? If we're doing it by hand, it's way easier to get to this one than it is to this one. If we're doing the calculator, it's easier to get to this one because it tells us automatically our answers. It's just the same number of button pushes. Okay? All right, you ready? You'll see what I mean now because I have to show you how to do it by hand. Because that's our last objective, or last two, is use the matrices to know how to do this. Okay? So here's our system. 3x plus y plus 2z equals 31. X plus y plus 2z equals 19. And x plus 3y plus 2z equals 25. Okay, so let's try to solve this one to just Gaussian. Let's get zeros down here and a diagonal of ones. Okay, now I'm going to use the row operations notation for you so that when we do get into our homework, you know what they all mean. Is that okay? Yes? So let's put this into just a matrix, straight up matrix first. Okay? So 3, 1, 2, 31. And 1, 1, 2, 19. And 1, 3, 2, 25. Okay? Now, what do I need in my top left-hand column? A 1. Okay? So how do you want to go about trying to get a 1 right there? Let's take row 1 and switch it with row 2. Now, notice where I wrote that. Where did I write it? In the top row. Okay? That's where I want to leave stuff. Okay? So if I switch row 1 and row 2, I have 1, 1, 2, 19. And I have 3, 1, 2, 31. And then I just leave row 3 alone. Okay? So the top row is perfect exactly for what I need, right? Because I need 1 and a number and a number and a number, right? So it's just these bottom 2 rows that I have to mess with. Okay? So let's do this next. Let's take -3 times row 1 and add it to row 2. Notice, where did I write that? Beside row 2. That means when I do all this stuff, I want my answer written in row 2. So I can go ahead and write my matrix 1, 1, 2, 19, row 1, and I can actually go ahead and write row 3 because neither one of those rows are going to change, are they? Okay. So let's multiply the top row by -3 and add it to row 2. So 1 times -3 plus 3, 0. -3 times 1. Hold on. I was pointing at the wrong thing. -3 times 1. -3 plus 1. -2. And then 2 times -3. -6 plus 2. -4. And then 19 times -3. Plus 31. Okay? Now, I want to see if you can figure out what we should do next. Think about what we need. And look at what we have. What do I need right here? What could I do? right? Is that going to give me what I need? Okay. 1, 1, 2, 19, and 1, 3, 2, 25. If I multiply row 2 by negative 1/2, what do I get? 0, 1, divided by negative 2. Remember, that's all we're doing. Multiplying by negative 1/2 and dividing by negative 2 are the same, right? So it's negative 4 divided by negative 2. And negative 26 divided by negative 2. How close are we getting? Right, right, right. I still have these 3 to fix, right? Okay. Any guesses on how you want to go about fixing that? Now that you've seen some of the steps we can do, what does this one need to be? A 0. What if I take row 3 and subtract row 1? Can I do that? So row 1 is going to stay the same, and row 2 we're going to stay the same, both of these. To get row 3, we're going to say 1 minus 1. 3 minus 1. 2. 2 minus 2. 0. 25 minus 19. 6. This is what I need. 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 I still need to fix these 2, don't I? Okay. So I'm still messing with row 3. What if I multiplied it by 2, the second row by 2, and subtracted row 3? Is that going to give me what I need? Okay. Do you see that? If I multiply this by 2 and subtract that, I need a 0 right here, right? Okay. I got to come up here. So 1, 1, 2, 19. 0, 1, 2, 13. So multiply row 2 by 2. 2 times 0 plus 0. I mean minus 0. Yeah, still 0, right? 2 times 2. 1 times 2. 2 minus 2. 0. Now 2 times 2. Minus 0. 4. 13 times 2. Minus 6. 20. Tell me what I need to do. What do I need? 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 One, 1, 2, 19. 0, 1, 2, 13. Divide the whole entire row by 4. So 0, 0, 1, 5. If I'm trying to get this into Gaussian form, have I succeeded? Do I have a diagonal of 1s and a little triangle of 0s? Yes. So please convert this back into an equation for me. So Gracie, while I can't see the answer by looking over here, I know what z is. See, this is what I was saying. We could take z and put it in right there. And couldn't I find y that way? And once I knew y and z, couldn't I put it in the top equation? Yeah. Does that make sense? Yeah, I don't like doing it by hand either, right? But this is part of the stuff that we're required to learn, yes? It's like a puzzle. That's exactly what it is. Okay? Do you have any questions?